here are the tuples and sequences we were talking about. So a tuple, we can define it this way. It's like, okay, it's like you define a tuple like this, for example, name, last name, 1, 2, 3, 4, like a pin or something, and you can access T0 here, for example. You can access it like a list, and here you can view the tuple. It will be between parentheses instead of between brackets, and here you can also combine tuples. So you have this first tuple and combined to the second tuple. It gives you even a combination of 2 tuples. This is what I was saying, that the main difference between list and tuple is this one, is that the tuples are immutable. So if you want to change the value of T0, you can't change this value. But you can still have mutable elements in the tuple. So this is, for example, a tuple, and if I want to do v0 of 0 equal 9, I still can do it. I can actually change the value of this one. So tuples are immutable, but if they contain a mutable element in them, like immutable and unchangeable, if they contain some changeable element inside of them, like a list, for example, we can change that element inside of it, but we can't change this element, like the element of the tuple, we can't change it. Like this one, we can change, but if we do something like this, we can't do it, since the tuple object does not support item assignment with type error. So next, we can there are 2 special cases actually in the tuple, is to create tuples of 0 elements and of 1 element. So a tuple of 0 elements would look like this. It's an empty tuple, and a tuple with 1 element, we have to leave a trailing comma here after the tuple. So here you see len of empty is 0, but still len of singleton is 1. You can notice here, and it's not the length of the string, but it's length of the tuple. And here you can see that singleton is actually a tuple, and it's totally okay to leave a trailing comma here for tuples. Here we can unpack the values of a tuple to variables. Here you can see that we have the values in here from earlier, from T. And that's mostly it about tuples. Next are the sets. Sets are collections that do not. We create tuples with those curly brackets, and with sets, the printing value, the return value, is the value without the duplicates. If here you see we have apple, and orange, we will have them just once. So that's what we have in this set. So, and we can test if orange is in baskets, and it's really fast membership testing, since you have just 1 element of each. So here they say 2. This is false, this one is in baskets 2, this is not in baskets, so it's false. And here we can do sets of some complicated letters, and here we can see, for example, here we can also see what is B. So here what A minus B is letters that are in, those are sets operations, like the mathematical sets. So letters in A that are not in B. A or B is the letters that are in A and in B. A and B, it's letters here, just to say, when I say and, to not really confuse you, when I say A or B, the letters that are they should be like letter have to be either in A or either in B. So the whole collection of the letters, like the whole letters from A and B. But when we say A and B, they have to be letters in A and in B. Those are like, if you know the operations from mathematics, they are like those set operations. But if you're not familiar with mathematics, that it's like this. It's like here it's the intersection of A and B, and here it's and also those concepts are mathematical, but also like quite understandable semantically and humanly. And here it's more the union of A and B. Yeah, and here it's the XOR, if you're familiar with this operator, and it's in A but in A or B, but not in both. Not the elements in both the sets. For example, if you see here, we have A, we won't have A here. So this actually you remove this intersection. Actually, it's A, it's this. Actually, this one it's equal to this one minus minus this one. This is actually even the no. Let's make it this way. We have to. Okay, this is even the formal definition of what is XOR, or what is the like just all the elements besides the intersections, all the elements of both sets besides the intersection. And this one is equal to this one. Next would be to use sets with list comprehension. All the operations that are in list comprehension are also usable in set comprehension.